Okay, we're going to do part C of Mock AB1. So this is pretty abstract and I would say a difficult limit, but follow this through, go back and relook at it again to make sure you understand what's going on. So first let's read it. For x is not equal to 3, the function k is defined by k of x equals the integral in the numerator, which involves the derivative, so that's the graph that we have, minus 4x. And then in the denominator is a different function, 3e raised to the power of 2 times f of x, this is the function f, plus 5 minus x. It is known that the limit as x approaches 3 of k of x can be evaluated using L'Hopital's rule. Find f of 3 and evaluate the limit of k of x as x approaches 3. Okay, so if it can be evaluated by L'Hopital's rule, that means the numerator and the denominator are equal to 0 when you substitute in x equals 3. So that's what's going to allow us to find f of 3. We know that this denominator, when we plug in 3e raised to the 2 times f of x plus 5 minus x is equal to 0 when x is 3. That's what L'Hopital's rule says, that if you plug in direct substitution of value and you get 0 in the numerator, 0 in the denominator, you can use L'Hopital's rule. So let's substitute in x equals 3 because we're asked to find f of 3. So 3e to the 2 times f of 3 plus 5 minus 3 equals 0. So now let's add 3 to both sides. So we get 3e to the 2 times f of 3 plus 5 equals 3. Divide by 3, and that gives us e raised to the 2 times f of 3 plus 5 equals 1. Well, how do we solve an equation that has e in it? We need to take the natural log of both sides. So the ln of e to the 2 times f of 3 plus 5 equals the ln of 1. The ln of 1 is 0, and remember this is a property. The ln of e to the x, whatever that value is always equal to x. So this is going to give us 2 times f of 3 plus 5 equals 0. So now we can solve for f of 3. Subtract 5 from both sides and divide by 2. So f of 3 is negative 5 halves. Okay, so that first part is finished. Okay, now it wants us to evaluate the limit, and if L'Hopital's rule can be used, that means we need to take the derivative of the numerator and denominator separately. So let's work on that. The limit as x approaches 3. I'm going to rewrite this down. Okay, so we're going to find that limit and we're going to use L'Hopital's rule. So that's going to give us the limit as x approaches 3. Now this part, when you take the derivative of an integral, that's your second fundamental theorem of calculus. And remember, you place t with the upper bound and then don't forget to take the derivative of the upper bound. So that numerator is going to equal constant coefficient 3 times f of 3x times the derivative of 3x. So that's the derivative of this integral. The derivative of negative 4x is minus 4. Okay, now the denominator requires using chain rule, because we're taking the derivative of e, constant coefficient of 3. The derivative of e is e raised to that same exponent times the derivative of the exponent. So it's going to be constant coefficient 2. The derivative of f of x is f prime of x. Derivative of 5, of course, is 0. And then the derivative of x is 1. Okay, so there's your derivative, and so let's now evaluate that when x is 3. So let's plug in x equals 3. So it's going to be 3 times f of 9 times 3 minus 4 divided by 3 e to the 2 times f of 3 plus 5 times 2 times f prime of x, oops, 3 in here, f prime of 3 minus 1. Okay, f 3 times 3, that's going to give us a 9. We need to go find f. This should be f prime, shouldn't it? Back here, f prime, f prime. We need to go find f prime of 9, which is on your graph. So let's look at the graph. Here's the derivative. When x is 9, y is 0. So that's 0. That whole term ends up being 0 minus 4. And now in the denominator, we have 3 times e to the, well, we already found the f of 3, right? So that's 2 times negative 5 halves plus 5. And now times 2f prime of 3. Let's look at the graph again. At x equals 3, there's an ordered pair. 3 halves. So that's, 3.5. So that's 3.5 minus 1. Okay, so doing this arithmetic, the numerator is negative 4. This is going to be 3 times, this ends up being 0. E to the 0 is 1. Times 2 times 3.5 minus 1. To do that arithmetic, see 3e to the 0 times 7 minus 1 gives you negative 4 over 20, or negative 1/5. Remember, on your exam, you do not have to simplify. Leaving it as negative 4 over 20 is fine. Leaving it like this is fine as well. Okay, so that was pretty complicated. Go through that again and look at that work and make sure you understand